When we divide complex numbers, we don't actually do anything that resembles division. We have a fraction consisting of two complex numbers, 2 plus I in the numerator, 4 minus 5I in the denominator. There really isn't a process for directly dividing complex numbers. So if we can multiply the denominator by something that will turn it into a real number, we're in business. In order to turn the denominator into a real number, we'd want to multiply it by its conjugate with the opposite sign in front of the imaginary component. And if we're going to multiply the fraction by anything, we're only allowed to multiply it by 1, so I have to make the numerator match the denominator. That way we're multiplying the original fraction by 1, which doesn't change its value. Now we multiply, like in the last set of examples, using the distributive property. 2 times 4, 2 times 5i, I times 4, I times 5i. In the denominator, 4 times 4, 4 times 5i, negative 5i times 4, and negative 5i times 5i. I want to remember that positive 5i squared is the same as negative 5. 8 minus 5 is 3. Add the imaginary terms. In the denominator, the imaginary terms cancel out. Negative 25i squared is actually positive 25. 16 plus 25 is 41. We're almost done, except that answer is not technically a complex number in standard form. To put it in standard form, we'll divide each term individually by 41. That should be a 41. And now we've got a complex number in standard form. Real number plus imaginary number. Next example. Multiply the numerator and denominator by the conjugate of the denominator. It's the denominator we're trying to turn into a real number. And for this one, we can actually simplify those fraction components. And we end up with a complex number in standard form.